We're on. Awesome. Okay, we are on page 98, and we're doing number 15, which is an elevator problem. The problem says, a person stands on a bathroom scale in a motionless elevator. When the elevator begins to move, the scale briefly reads only 0.75 of the person's regular weight. Calculate the acceleration of the elevator and find the direction of the accelerator. So here's the deal. A person in an elevator has a weight while motionless. And just like we showed with the medicine ball lately, when anything changes, when we toss the ball up and down while standing on the scale, it changed. If there's any change in acceleration of any part of the mass of the person or the system, 0.75% of the weight is what the scale showed when the elevator moved. Okay, this is a question that's going to sound more complicated than it is, and I suddenly decided I don't like writing in red. But, okay, there was a change in the weight. A weight is a force, right? For a force to change, if the force changed, one of these two, what else must have changed? To see a change in force, what must have actually changed?
Acceleration.
Acceleration. Technically, mass could have changed as well. But what are the odds that this guy lost a limb or gave birth?
Yeah. Very small.
Probably not. I think the problem would have mentioned something.
Yeah.
So I'm guessing that we're looking at a change in acceleration. Plus, they say the elevator moves, and for something to be motionless and then to move, it has to accelerate. They don't give any numbers for this, do they?
No.
Okay. Let's see if we can use some real-life experience to try and guide our thinking on this a bit. When an elevator goes up, do you feel lighter or heavier?
Heavier.
And when it goes down, do you feel lighter or
I
heavier?
feel like I
Lighter.
could dump.
I feel like you could dunk when it's going down. If we could get the floor of the basketball court and the basketball nets to drop, to be falling, you could dunk, actually. That'd be a very expensive basketball court to build, just to give you that experience. So the elevators, if the scale suddenly reads 0.75 of his weight, that's less, correct? Is this elevator going up or down?
Down.
Down, most of you were pointing. Good. Okay, so that's not mathematically proven. We can't use that to justify our answer, but we know we should have a downward acceleration. Okay? So let's see. If we went to 0.75 of the force involved, we must also have gone to 0.75 of the mass times acceleration involved, and you guys just told me that that's going to really be 0.75 of the acceleration, not the mass. Does this make a certain, is this a good way to write mathematically what we think is going on? Okay. Yes, Nate, you got a thought?
Question about working for last night. If you were to jump, like,
Oh, well, hold on. Let's do this from beginning to end. It's going to be really confusing for our absent people today. But hold that question. Try and remember for the end. Okay. Does this make sense to everyone else? Okay, now we started out with a guy standing motionless in a motionless elevator on a bathroom scale, right? So what was the acceleration involved then? What acceleration? He was putting a force on that scale
Gravity.
just by standing there, right? The only thing he was feeling was the acceleration due to gravity on his mass. Actually, the mutual attraction between him and the Earth, but it's a tug of war. Earth was winning because Earth is a lot bigger. So what we were really talking about was his weight equaled mass times gravity, and now 0.75% of his weight equals his mass times 0.75% of gravity. What's gravity equal in metric? 9.8, we usually 9.80 meters per second, same thing. So this guy's acceleration was 0.75 times 9.80 meters per second squared. What is that number? Who's got a calculator handy?
Come on, where'd it go?
I would ask Siri or my Google app, but my phone is busy right now.
Oh my.
Glad you found it. So what is this guy, what actual acceleration is he feeling?
7.35.
7.35 meters per second squared. Awesome. Okay. Let's do a little bit of a diagram over here. Gravity is pulling him down like that, right? The bathroom scale, and underneath that the floor of the elevator, Newton's third law, is pushing back up on him like that, correct? If you are either motionless or moving at a constant speed, these forces are opposite and equal. Equal in magnitude, opposite in direction, I should say.
Right.
If you're motionless, or even if the elevator is moving at a constant speed, you need acceleration to feel any difference in this. Okay, but he didn't feel that. He felt the bathroom scale was only pushing back up with 0.75 of that. All right? So he's going down with what acceleration? That means he was only pushing with that much. We know he's going down. What is the acceleration of the elevator?
7.35 meters per second squared.
Nope.
Oh, wait.
That's what he still feels downward. How much acceleration is being taken away from gravity?
Oh. 2.5. Yeah.
So where are you guys getting that?
9.8 minus 7.35.
The actual acceleration of the elevator is 9.80 meters per second squared minus 7.35 meters per second squared. And it is 2.45 meters per second squared, and we said the elevator was going downward. That's its acceleration vector. Any questions on that?
No, sir.
The hard part about that is they gave you no numbers to deal with. None at all. So this downward acceleration throws everything out of balance. This is what's happening when you're moving at a constant speed. You start going downward, these are no longer equal but opposite. I'm going to hold off on the other thing I was going to do because we haven't talked about free body diagrams yet. We'll get to those right after Christmas break. And we'll show you how to look at this slightly differently. But you know if you're feeling lighter, the elevator's going down, right?
Right.
Okay.
That's
So if the scale weighs less, the elevator's going down. If it weighs more, the elevator's going up. Any questions? Going once? Going twice?
Wait, we do 13.
Yep, we're going to do 13 next.
Okay.
All right. I like how little information you can be given and still answer this. You didn't know the guy's weight. You didn't know the guy's mass. You assumed they were talking about an elevator on Earth, where the gravity is mostly 9.8